are the same as vegetable dyes. In order to maintain the medicinal qualities of these herbs, natural substances are put to the fabric. Moreover, fabric can be bleached without the use of chemical bleach by just exposing it to sunlight. The ancient Indian Vedic healing system known as Ayurveda is where the idea for the herbal textiles originated. Ayurveda has a branch called Ayurvastra. When combined, the Sanskrit term Ayur and Veda signify life, cloth, while Vastra implies clothes. Herbal and essential oils are incorporated into fabrics to create it. A variety of herbs, including herbs and essential oils, are incorporated into fabrics to create it. Many other herbs, including castor, tulsi, neem, rose, indigo, turmeric, lemongrass, can be utilized in this technique to give the cloth a fragrance and therapeutic quality. Ayur Vastra, which is sold under the brand name Cosmo Textiles, has been used to treat a number of illnesses, including hair fever, diabetes, arthritis, and skin infections. An old method of dyeing fabrics with therapeutic herbs is known as herbal clothing. This alternative therapy approach has its roots in India dating over back 5000 years. Its foundational ideas are found in the Vedas and old Hindu texts. The Vedas were composed approximately 3000 BC, around 1000 BC, when Ayurveda, the science of life, first appeared. The other Veda has reference to the origin of Ayurveda. It has songs and indications that use mantras to heal a variety of illness. According to mythology, Lord Brahma gave Dhanvantari the practice of Ayurveda. The earliest known Ayurvedic texts are the Chakra Samhita and Shustra Samhita. People from all around India use different types of natural dyeings. About a century ago, and they would repeatedly, organic cotton fabric is infused with a certain herbs and oils to create a herbal apparel that is beneficial to the weather's health. Herbal clothing or Ayurvastra has long been thought to be able to treat a variety of conditions, including cancer, diabetes, rheumatism, asthma, arthritis, and high blood pressure. There have been reports of antimicrobial properties of natural dyes such as Indian metal, pomegranate, myrobalan, and indigo being effective against bacteria like Klebsiella and phenomena and Ichthyosis coli. In Ayurveda, herbs like Hara, Raktaka Chand, and Shaswata Gandha and Kunguma are used to shield the skin from the sun harmful rays. The herbal remedies interact with the skin's melanocytes, adjusting their activity and preventing the skin's vulnerability to UV radiations. Ayurvedic writing contains numerous references that provides adequate examples of wearing pure cotton cloths impregnated with the herbs such as Chandana, Haridra, Ushada, Machista, and mainly Ashwagandha to safeguard human body from inclement weather and to keep it healthy. They used herbal products such as soap nut and lime for washing clothes before soaps and detergents were discovered. Herbal textiles and dyes have great vista of application in diverse walks of human life. The herbal dyes have been used for centuries to produce colors for fabrics, yarns, leathers, foods, and so on. Herbal contact technology and herbal textiles on body. The human body greatest sensory organ in the skin. It can serve as a conduct for some chemical to enter body as well as the barrier. Conventional clothing accumulates a number of pollutants and chemicals from the environment which can then enter the body through the skin. Therefore, improving skin barrier against the toxic and hazardous substance entering the body will benefit health. The fabric herbal molecules are activated by the heat radiation and are reflected back to the body with a cloth where they are absorbed deeply into the body, manifest the numerous body levels and aids the treatments of the range of illness. In addition to serve as a barrier of defense, the skin can also serve as a conduct for foreign substances to enter the body. Similar to this, the skin can absorb the herbs present in our all natural dyes. Wearing herbal cloths in close proximity of the skin speeds by the body's metabolism, facilitating the efficient removal of toxins from the body.
After screening. Sona.
And penetration of herbal molecules across the skin and herbal textiles and their medicinal properties. Herbs and garden plants planted and gathered for their fragrant, fibrous, medicinal, and culinary properties. Herbs are planted in gardens because of their distinct scents.
Herbal textiles and their medicinal
Domestic
properties.
applications.
First கொண்டுதான்
Concern has lead to a global
அதுக்கப்புறம் ஒருத்தவங்க
you
அப்புறம்
can use the herbs to get various shades of orange, brown, red, yellow, and green natural dyes for functional finishes. encouraging the eco-friendly way of living. Natural dyes are renewable material that are safe for the environment, non-toxic, non-carcinogenic, and non-allergic. While dyeing fabric using herbal dyes, only chemical-free herbal preparations are utilized. In contrast, while dyeing with vegetable colors, chemicals like copper sulfate and ferrous sulfate are employed as a catalyst. Because they also have some medical benefit, herbal dyes differ from vegetable dyes in this regard. It is thought that the wearing herbal clothing will boost the immunity and assist the body system return to balance. This is the table and the name of the herbs, medicinal properties, and diseases claimed to be cured. Neem will be cured by the disease. It's a common disease, skin allergy, control blood sugar level, and it has some medical properties like antibacterial and antifungal. And curry leaf is a medicinal value, beneficial in curing arthritis, suppression pain, and reduces inflammation. And hibiscus flowers are control the blood sugars for the diabetes. And fenugreek medicinal values controls cholesterol, hypertension. Amla is antifungal, antibacterial, and it boosts the immunity. And acacia antifunctional and antibacterial used for treatment of parasitic infections and itchings. Manchista is a medicinal value, is for blood purifier and leprosy. Yes, okay. And turmeric is also the antibiotoxic and antioxidant, antimicrobial, antiseptic, and anti-allergic. It fights the skin diseases and helps fight skin diseases, anemia, and liver disorders. And henna is a blood purifier, anti-irritant. It's a skin irritation such as heat rashes and skin allergies, and to cool the body. And Brazilwood and Indian mulberry is also antimicrobial and antibacterial inflammation. It is a blood purifier and used for the wound healing, control diabetes. Materials and methods to extract the dye, several plants pots are utilized, including the roots, barks, leaves, fruits, and wood seeds and flowers. Only roughly 150 and estimated 2,000 pigments presented in the different plant pots have been used commercially. A specific method for producing herbal textiles involves using extraction of certain plants to color cotton, silk, linen, yarn, and fabric. At no point are synthetic or artificial dyes utilized, and only particular products are used for washing. The long established dyeing techniques used since the era of Indus cultivation led to development of the process of herbal dyeing through the intensive research. First, 100% of hand loomed organic cotton or silk, wool, linen, jute, hemp, and so forth are used for the manufacturing of a herbal textiles. These natural mixes are then specially dyed with the herbal infuse for both color and the health benefits. The fabric is processed and dyed without the use of chemicals. Before the fabrics are made into a complete goods, they must go through a number of treatment phases. Textiles made from herbs are exceptionally smooth and conductive to the perspiration, which aids in the healing of the variety of illness. Certain plants that are known to treat illness are infused to each fabric. It could be beneficial in treating various illness and skin infections, including psoriasis and eczema. The fabric also relieves blood pressures, diabetes, arthritis, heart problem, and respiratory issues like asthma and sleep disturbance also. It also strengthens the immunity. Herbal medicated clothings, antimicrobial and antibacterial qualities allow it to be used in the bandages and dressings. And herbal dyeing process. The process of making the herbal textile starts with a pure organic yarn on fabric, and every stage is done by hand with great care and attention to detail, and without the use of chemical dyeing and processing techniques. The grey cloth must first go through the number of treatment steps before it can be colored and made ready for wearing. Herbal dyeing should only be done on natural cotton, silk, wool, linen, jute, hemp, and certified organic cotton, as well as their natural blends. The lengthy research that followed led to the development of the herbal dyeing textiles, which has been used since in the Indian culture. Herbal clothing is made without the use of a machine, and all procedures, including bleaching, dyeing, and other procedures, are carried out in large vessels made to order. Additionally, no chemicals are added during weaving, spinning, or starting with a pure organic yarn or fabric. The process of creating the herbal textiles is carried out of step by step by hand. That meticulous attention to details without the use of the chemical dyeing. Only natural cotton, silk, wool, linen, jute, hemp, and certified organic cotton together with the natural blend should be dried with the herbs. The extensive research that ensured resulted in the setting of the herbal dyeing method, which has been participated in dyeing in the Indus civilization. Machines are not used in the production of herbal clothing. Instead, all process like as bleaching and dyeing are carried out by hand. Before the grey cloth can be dyed and prepared for wearing, it must first go through the several treatment stages. Only natural cotton, silk, wool, and hemp and certified organic are together natural blends should be dyed with herbs. The extensive researches that ensued resulted in a certain of the herbal dyeing method, which has been practiced since in Indus civilization. All process such as bleaching, dyeing, and process are done by the hand in sealable custom-made vessels, which makes herbal apparel. Furthermore, no chemicals are added. And desizing, it involves washing of the processed grey cloth with mineral-rich water and sea salt to remove sizing, gums, and oil used in the weaving. And bleaching, sun drying, and organic biodegradable cleaning chemicals and surfactants are used to carry out this procedure. Cloths can be ordinarily bleached by the employing animal manure and sunlight on the natural grass foundation. Using cow urine, milk, honey, and degradable organic cleaning chemicals that came from the nature, together with a surfactant and like supla and fluffer, the cloth or yarn is first bleached. Cow's urine is particularly beneficial according to many Ayurvedic doctors to strengthen the immune systems. Moderating and dyeing medications. Moderating to make the color look bright and retain color fastness, natural modern such as micrograms, rhubarb leaves, oils, alum, fruit extractions of Haritaki, bark of larger minerals, and ions are used. Use of heavy metallic moderns such as copper, chrome, zinc, and tin is avoided as they are not eco-friendly. And dyeing is since medical herbs are employed to give a cloth or yarn to the desired color, the word medicine is used instead of dyeing. Depending on the condition being treated, the yarn or fabric is subsequently medicated using carefully regulated blend of herbal medical treatments to preserve the medical potential of the herbs. The necessary herbs are put directly to the fabric with the aid of natural components. The following are the steps are involved. The yarn of fabric made of organic cotton is meticulously dyed using a mixture of herbal dyes that are recommended for the intense sickness or diseases. There are therapeutic herbs that are extracted from plants, flowers, roots, and barks are carefully blended to extract the herbal dyes. Technologies used for herbal finishing. Essential oils and herbal extract finishers are used into the fabrics to create the herbal textiles. The textiles can be used to give a clothing fragrance and medical benefits. Herbal medicines and oils are incorporated into textiles through the use of micro encapsulations, coated textile technology, liposomes, dyes, and sensory perception technology. Temperature at which the finish is applied, plant extract, lengthen the concentration, herb blend, and even equipment employed are all meticulously regulated. Several procedures are frequently employed for textile finishes by microencapsulations, including spray drying, air suspension coating, solvent evaporation, soldier microprension, and in situ polymerization. Spray drying is a technique used in the encapsulation taste and fragrance and oil. It involves dispersing the core particles in the polymer solution, spraying them in the heated chamber, which result initial particles solidification on core material, result in the formation of polynuclear or matrix types of microcapsulations. Textiles have been treated with antifungal finishes uses by the method of solvent evaporation, which involves dispersing, emulsifying, or dissolving the medication in the external aqueous or oil phase. Textiles that are flame retardant, water, oil resistant, UV protective, antifungal, self-cleaning, odor, and flavor containing antimicrobial are made up of sodial micro-encapsulations. In the process of creating sodial silicon monomer in the hydrolyzed silicon is condensed into the core structure with a three-dimensional network structure. This can be tailored for a wide range of useful properties. And micro encapsulations in cosmetic textiles and micro encapsulations for antimicrobial finishes. Cosmetics textiles are making the transition from labs to showroom thanks to the new textile technology that allows the cosmetic components to
Miss
be
Sona?
applied on fabric and deliver their functional
Miss Sona?
advantage to the final product. One finish that fits
Miss
into the
Sona, time up.
category is fragrance finish. An aromatic substance with a pleasing scent is used to create a fragrance. The study of
Miss
aromatology
Sona,
examines
time up.
how scents affect. Yeah.
Time up.
Oh, okay, ma'am. I'm going for conclusion.
Try to conclude.
Yeah. Drawbacks in the herbal fabric and dyes are not good substituted for the synthetic dyes offering broader range of variations. retaining color and its herbal benefits demand utmost care in washing. Herbal cloth should be washed separately, preferably hand wash or gentle machine wash will bleach-free detergent and should be hand dried. This cause inconvenience to the users. My conclusion is the textile industry is constantly looking for solution to this issue after realizing how much it uses as a hazard chemical during production contributing to environmental contaminations. One significant step towards adopting an organic lifestyle and lowering environmental pollution is the use of herbal dyes. Herbal textile goods are free of many of the common illness associated with traditional cloths because they don't include the pesticides, fertilizers, antibiotics, growth hormones, genetically modified organisms, and chemicals, irritation, or sewage sludge. One excellent strategy for leading a healthy lifestyle is to combine the textile used to combine the herbal textile have a lot of potential in the global textile market and could grow to be the significant textile product in the future. One excellent strategy for leading the healthy lifestyle is to combine the textiles and herbs to promote the health in an environmentally reasonable way. Globally, there is growing awareness of herbal cloths. One of the best way to boost the revitalize the Indian handloom sector in the global textile market is through use of herbal treatment in the textile protection. Yes. Yeah, that's it. My conclusion. Thank you.
Uh, Sona, is it your review paper or are you involved in any project on this area?
Sir, this is my review paper, and I am doing my project using this only, but I do not reveal my project. So, but this is my review paper only, sir.
Okay, so what is
So,
your
I am
comment?
doing herbal finishes on my project, sir, PhD project.
Okay, fine. What is your comment on preparation of the fabric? Because you have been telling all the way that it's only a gray fabric. You have mentioned it specifically, right?
Yeah.
How are you
Yes,
going
sir.
to apply any herb or any natural substance on a gray fabric? You know, textile, there are natural oils and wax substances covered on the fabric.
Yeah. Yes, sir.
How are you going to remove that naturally?
By desizing.
How?
Pre-treatment, sir. I will go for the pre-treatment before doing this finishes. I will go for the pre-treatment.
With pre-treatment with?
With herbs, we can use the herbs, sir, but by chance we can use some bleaching substances
Okay.
like that.
If you are not sure, just have a look at it because that would be the challenge more than application of the herb.
Okay, sure, sir.
Because many, so that is our weakness currently in the application of natural substances.
Yeah, sure, sir. But I have to concentrate on that, sir.
Yes, fine. Okay, okay, take care.
Thank you so
Is
much,
there
sir.
anybody would like to talk?
Suppose if any queries you can ask. Ms. Sona, thank you for your presentation. Now I would like to call Ms. Anish Sharmila M from Hindustan Institute of Technology and Science, Chennai. The topic for your presentation is impact of agrotextile and you can start your presentation. So kindly strictly maintain with the timings. So 10 minutes for your presentation and 5 minutes for your interaction with the speaker. You can start, ma'am. Kindly unmute your video during interaction.
Good afternoon, one and all present here for the conference. Myself, Dr. Anish Sharmila M from Hindustan University. My paper title is Impact of Agrotextiles on Amblyomys esculentus plant growth and its yield. And thousands of years ago, people began to cultivate the plants and water is the most important source of agriculture. And due to the scarcity of water, some of the various technical methods are used nowadays, and we have to improve the crop cultivations by using the less number of waters. And under these conditions, an important challenges for farmers and managers, engineers and researchers is to expand and adopt
Ma'am,
the
wait a minute.
practice and
Wait a minute,
techniques,
ma'am.
yeah,
Please.
that promote the, yes,
Hello, ma'am. Are you?
yes sir,
Yeah.
yes sir.
Please switch it to full mode, full screen mode.
Okay,
Press or F5 or yeah.
yeah, is this okay sir?
Yeah, it's visible.
Hmm.
And also, if possible, unmute your video.
No sir, it's enough sir. It's audible sir, or visible and everything
Yeah,
is
okay,
okay?
it's visible.
Okay sir. In this current study to improve the plant growth and with the advanced technology or of the organic productions using the agrotextiles, and in this study I used for the coir pot is the base material, and with the lining of cotton, jute, banana and denim fabrics with the liner used for the further productions of amblyophones and esculentes. It's a orca. It's called as a colloquial language. It's called the orca as a lady's finger plant. And coir is an excellent material to highly absorb the water, and even the rainy days it played a role of a lot in even a few square feet. It extract the water, the fiber. It is the huge amount of water. Let's keep it with us. And the extraction of the unit of coconut fiber is uh, accumulating in the same locality. Some of the waste coconut um, disposable is a main problem. And in this study we have to that sustainable development we applied in the coir dust, and coir pith is the major dusty materials. And in this study we use the base materials of coir pith to made up of a coir part. And in India, and 7.5 million tons of large quantity of coir waste is available, um, especially in Kerala, Andhra Pradesh, Tamil Nadu, Karnataka, and some of the other states. The cellulose, this is the cellulosic fabrics and fibers absorbed with the waters with this particular movement. And this entire study was focused on the coir part incorporate with the textile material by planting uh, the orca products. And the process is water requirement, basically 2.5 centimeter of water a week is needed, and the temperature basically 25 degrees to 35 degrees Celsius temperature is needed, and it cannot tolerate less than 10 degrees Celsius, and it's a normal planting temperature only. And the pot preparation is 5 parts we selected, and 3-gallon size, and total 10 to 12 inch deep in diameter coir part is selected. And the next method is a propagations method. In this germination process is soaking the seed in a warm water for 24 hours before the planting. And especially this is a summer crop and harvested with the humidity temperature. And the first stage of seed propagations, everyone is visible in this picture, and we put in the coir pot with the lining materials. And the germination, after this germination process, the second stage of vegetation and growth, the root system is able to support the growth, so the plant is need lot of nitrogen in order to create the chlorophyll. So it's required the nutritional requirement as well as the growth of stem and branch and leaves. So as well as the third stage of reproductive and floral stage, mainly it's producing the fruits and seeds, flowers. And the 35th day of Abel Moscos esculentous vegetations, it shows the blooming. And finally, in 40th days of harvested stage, we got the best result in banana. We got the best result in banana fiber lining coir part. The analysis part we made in a fig mode curve. In that fig mode is the analysis part. It's starting it slowly with log phase and increasing speed of log phase, and slow down is decreasing rate, and it stops the steady stage. In this assessment, concluded that the banana fiber lining pot have the vegetables height is 17 centimeter, and cotton lining fibers 13 centimeter, in as well as the denim part of fabric lining coir pot is 8.5 centimeter. And this is the table, the vegetables and the plant growth, as well as the plant growth and the lining material of the figure representation for the comparison of plant development in over 48 days. And final, the conclusion is overall, we have to see the growth and process of characterized is main size of growing the part of the plant and as well as the vegetables. And this banana fiber lining coir part have demonstrated, and it given the rate of growing is 32.8 centimeter, and the excellent crop and measuring is 70 centimeter vegetables in the plant. It's greatly aided by the banana fibers. Thank you.
Thank you. Thank you, ma'am. Kindly unmute your video, ma'am, for interaction.
Dr. Ramya? Anish Sharmila. Okay. Am I audible, Miss Anish?
Yes, sir.
Fine.
Yeah.
It seems your work, it's not a review paper. Am I right?
No,
it's your research work.
Yes, sir.
Only two questions.
Okay.
To be precise, I think put it in Tamil. நீங்க வந்து வெண்டைக்காய் வந்து டிஃபரண்ட் பாட்ஸில் வந்து எப்படி growth rate இருக்குன்னு சொல்லிட்டு மீடியம் ட்ரை பண்ணியிருக்கீங்க. Am I right?
Yes, sir. Yes, sir.
Okay, fine. Since you used that botanical name, even it was new. Okay, good. So why the pictures of B and D missing in your photograph?
Pictures of
B and D, because you have shown.
Because it's not grown, sir.
Oh, okay, fine.
Yeah.
Then second thing, actually you have finally concluded that banana fiber lining
Yes.
put in the coir pot gives the best result in the growth of this plant. Am I right?
Yes, sir.
That's how you conclude. Okay.
Yes, conclude.
What is the justification you are giving for that?
So already the coir have a property to hold the water content, and some of the plastic nowadays the everyone's having that plastic and reusable cloth things they are using. So it's harm to some of the plastic bags. It's harm to the environment. That's why it's already the coir is going to waste ton and million coils is going to waste for. So that rare productions, and with the textile material, why I choose the textile materials, textile is a degradable material. It's a natural, all natural fibers. So like a pilot study I tried.
Okay, see coir already is going to hold, even coir
Yes.
pith composted material can hold more than sufficient water. So in that case, then what is the need of banana leaf lining inside that?
Yes, sir. Some of the nutrition values like
Does it release some nutrients during the composting process?
that I didn't analyze, but in this is the comparison I did with the thing. What is the role in the lining if we are given the lining? how we get the result.
Have you consulted during the research design, have you consulted any of the agriculture or horticulture department people
No, no,
about
no,
your
no,
work?
no.
Kindly do
Not
that,
yet,
because
not yet.
they are very systematic in the approach, because we are into textiles. So
Yes.
it is better always approach them, and they will give you a clear picture about whenever there is a research, how to make the research design, and there is a flaw in it. So that you have to understand clearly.
Okay, okay, sir.
Fine,
Thank you,
fine,
sir. Thank
do
you for the
that.
suggestions. Thank
Okay. Fine. Anyway, it's a good attempt.
you. Thank you, sir.
So is there anybody else who would like to ask some questions?
Thank you, ma'am. Such a wonderful presentation.
Okay,
I would
thank
like
you,
to invite to Miss T. Menaha, Sona College of Technology, Salem. The topic of development of combined technology on to shoot government requirements in technical textile application. Miss Menaha, ma'am, your presentation time is 10 minutes and the 5 minutes for interactions. While interactions, unmute your video. Kindly follow the instructions, ma'am. Miss Menaga, ma'am, can you hear me? Miss Menaga, ma'am, unmute your audio, ma'am, and you can start your presentation, ma'am. Miss Menaga, ma'am, any issue, ma'am?
Mute. Sir, is it visible, sir?
Yes, ma'am, visible, ma'am. You can start your presentation, ma'am.
Yes. Good afternoon, everyone. So my topic is development of combined technology on to suit the government requirements in technical textile application. So myself and Mr. Dr. Ramesh Kumar, so Associate Professor, Sona College of Technology. So next slide. Next slide. Hello, is it? Hello.
Hello, ma'am. Ma'am, it's visible, ma'am.
Second slide, madam.
Second slide. Second slide.
Hello.
Ma'am, please wait, ma'am. 2 minutes, ma'am.
Okay, madam.
Are you visible, ma'am?
Yes.
Ma'am, your slide to its introduction, ma'am.
No, no, madam.
What's the topic of slides 2?
Hello.
Ma'am, visible, ma'am. Second slide, it's the second slide, ma'am.
Okay. So here the yarn spinning. So the first they are using the blow room as well as the cording. So the fiber should be opened at the cleaning process in blow room stage, and the fiber to fiber separation is done in cording short. That is called in the cording short. It is called as the heart of the spinning, and it plays the vital role in yarn parameters. So the separate individual fiber again combined and form the structure called as sliver, which we are getting to an output of the cording short and increase the number of fibers. fibers in the yarn cross sections, and we are adding the more fibers and get the combined single fiber, and the next process is the formulation of roving frame, and finally the roving should be converted to be the hanger count. The ultimate end product should be is the yarn section yarn. So next slide. So here the yarn spinning overview. The first one is the opening, then after that cleaning, then after that the fiber separation, then individualization, then hooks removal, then after that the strengthening with more number of individual fibers, then after that combined single fiber, then roving, then finally the output is yarn. So here the yarn spinning concept. So here two types of yarn spinning concept is there. One is called conventional and another one is called current trend which we are using. So old trend is called ring spinning. So now we are using the draft systems, then open end spinning, vortex spinning, compact spinning. So yarn spinning raw materials. So here we have to use the when we are getting the yarn, we have to use the natural fibers or the man-made fibers or the regenerated fibers or the synthetic fibers. So the yarn spinning value addition. So here the slab, it should be combined with compact Syro. Otherwise it should be combined with the Syro, or the slab should be combined in injection slab, or then it should be combined with core. So finally the end product should be an yarn. So yarn spinning, so unless we add some value addition to the existing yarn, it is not easy to survive in the industry. So we are using the combined technology of manufacturing the yarn and to produce the camouflage background yarn with the possible core component. So during possible core component. So here, during yarn spinning, the textile expert commonly control the series of parameters, like the main parameter should be of fiber strength, fiber length, the twist yarn, yarn count, and the fineness. So here, on the basis of the skill, the expect operators should be a qualitative raw prediction of yarn strength. Unfortunately, the empirical estimation of actual value of this strength is also not straightforward. So the considerable number of predictive models has been implemented to evaluate some yarn property like strength, elongation, evenness, as well as the imperfection like hairiness, etc. So here, the producing the yarn with multi number of feed packages, we have to supply the creel to have the difficult task to involving the different techniques of yarn manufacturing technology of ring spinning system. Arriving this final yarn in the same ring spinning platform to give we have to check the cost effectiveness of the production oriented benefits. So combined technology. So first we have to give the Syro concept. In that we have to use the core concept also. In that we have to use the injection flap concept also. So we are using the three concepts, that is injection flap concept, Syro concept, and core concept. So materials and methods. So here the raw materials always with the blend composition. We have to use the two types of blend. Maybe it is a natural or synthetic. Based on the color effect, we have choose the base as well as the injection portions, as well as the Syro with the supply the two base, and subsequently the two injection portions give the field to give the Syro, and finally the yarn is formulated to core, may be extended to be the end use application. So here the value addition, the cost addition also we have to be checked, and we need to have sustainability, and we need to extend the service for the end users. So the materials and methods, the thinking of camouflage effect in the yarn body, it is based on the raw material selection, and we should give the dyed and melange combination mixed with the roving feed package. It comes across the blow room mix in the fiber stage. As well as we have to give the multiple options of raw material selections, since we have opened for multiple feed packages in the feeding show, as well as the considering the chemical nature of the fiber, we can choose the multiple combination of cellulosic, non-cellulosic, as well as the man-made fibers and synthetic natural fibers. with more or less equal to stable length, it gives the better performance of ring spinning process. And also the combinations of multiple or the sets of multiple raw material in the final yarn, definitely it gives the remarkable result of yarn parameters like strength, elongation, moisture content, moisture recovery parameters, and bulkiness of the physical yarn properties. So, and also we have to check the cost of the final product, may decide the raw material selection as well as it should be, and we have to check whether it is an eco-friendly for other related parameters. So as well as the multiple feed packages are going to supply the feed material in different shown for top warm, and this row can be converted to yarn by attaining the draft in terms of break draft as well as the main draft, coming to back roller as well as the middle roller, as well as the combining to cords, shore hardness, top arm loading system, spacers, apron in the top and bottom saddle settings, as well as the back roller settings to subject the final yarn appearance, and the count of the yarn are really need to be a delivery side. So as usual, the core component may give the final stage of the yarn forming to be the front set of rollers. The rest of the yarn path may be completed with the same ring spinning concept of ring and spindle. So the outcome of the topic is, so yarn from the multiple feed package in the feeding shore. So here the raw material we have choose more option, maybe it is natural or synthetic. The feed hang must be preferable in the finer side. Like that we have to use the finer fiber dyed as well as the combination dyed effect also we can get in the process. And also the core component may be used as a conductive part. It so improves the yarn basic parameters and equips the yarn to be used for the technical textile application. In knitting also we can get the pre-measured fabric with the camouflage effect. So the amount of fabric or the garment as per the standards. So the results. So yarn result like yarn strength and the strength are measured. So in fabric, all the fabric related parameters like abrasion, GSM, tear strength, bending modulus, pilling are also measured in this area. So the garments also we have the end use application. So as well as we have to check the color fastness and wash fastness of the garment are verified. Wicking, air permeability and other materials related parameters should be also be checked. So conclusion. So the newly developed multi-technology yarns are involved in various application and parameters are account for further developments. Thank you.
Menaka.
Yes, sir.
You hear me, right. So, to my understanding, you are trying to develop some camouflage effect in the fabric using a combined technology which you claim. Am I right?
Yes, sir.
What do you specify the term combined technology?
Combined technology means we are using the three types of concept, sir.
What
that is silo concept, injection slab concept and core concept.
So what is the expected outcome? Camouflage effect.
Camouflage effect, sir.
On what basis you expect this effect?
We are further processing and doing the project, sir.
Okay, so you have already done or doing the work?
Doing the work, sir.
But you have mentioned like materials and methods, results, but no data is shown now.
Methods, it is a processing, sir. It is a processing on stage.
But results, you have titled a slide results, but no results were there, na?
It is on processing, sir. We are doing, sir.
Okay, so even when you use a melange yarn, you may get a camouflage effect. What is the need for this combination of this technology?
What, sir? I can't understand, sir.
See, this camouflage effect can be brought out in a material by printing, or even your melange yarn or your tie and dye can bring these effects. What is the
yes, sir.
What is
but we are using the weaving. Weaving we are using, sir.
Now see already there are 2-3 techniques available to produce camouflage effect. Now what is the need to go for a new technology?
Sir, already it is having the printed in camouflage effect, sir. So now we are using only for weaving. That means in yarn we have get the different colors. Even single yarn we have get the different colors.
You go for tie and dye.
That means the dyeing process, weaving itself, in spinning itself we are getting, sir.
But obviously you will use fiber dyeing, na?
Yes, sir.
So at some point of time you are going to do the dyeing, otherwise you won't get the color, na? You got my point? See, I am not questioning your concept, I am just getting the clarification, that's it. You might expect some questions like this in the future. You are a research scholar, na?
Yes, sir.
That's why. Okay, so you can expect such questions. Anyhow, you need not answer right now, you can get it prepared. You got my point. When there is already some technology existing to get that effect, then why should I go for a new technology? That will be the first question. There should be some cost benefit, or there should be some new innovative patterns of designs in the camouflage which cannot be produced by the any other existing technology. So you should climb like that, only then you can go for a innovation technology. It is not just like that we combine 2 or 3 technologies and claim that I have done an innovation, unless you get a new result. That's the point.
Okay, sir.
You got it.
Okay,
Dr. Ramesh with you right now?
What, sir?
Is Dr. Ramesh with you right now?
No, sir. No, sir.
Okay, fine. He's my best friend, convey my regards to him, I know him. Okay. Any
sir.
other
Fine.
questions? Okay, Menaka, best of luck.
Okay, thank you, sir.
Thank you, Ms. Menaka. That was such a nice presentation. Now I would like to call Ms. P. Dhanlakshmi from the Gandhipuram Rural Institute. The topic is evaluation of antibacterial activity of Thesis-Pia populana flower extract. Ma'am, you can start your presentation. The timing is 10 minutes for your presentation and 5 minutes for the interaction.
Yes, ma'am. Shall I start my presentation, ma'am?
Yes, ma'am, you can.
Yes, ma'am. So, very good afternoon, one all to present here. Myself, Dhanlakshmi, I am doing as a PhD research program under the guidance of Dr. R.A. Satya, ma'am, the Department of Home Science, Gandhigram Rural Institute, Gandhigram. So, my topic is evaluation of antimicrobial activity of Dyspepsia populana flower extracts in khadi fabric. The natural dyes can be obtained by different sources, and it has a variety ranges of shades, and the plants are the most important source for the natural colorants and can be obtained from various parts like stem, leaf, flower, fruits, and seed, and pills are utilized to extract the natural colorants. The natural dyes can be extracted from various natural resources and obtained from roots, barks, flowers, and fruits. And from these studies, I have chosen for the Dyspepsia populana Solan X Crocia is an evergreen family of Malvaceae family. And based on that, the name of the plant is now in English as an Indian tulip tree, and Bahanda in Sanskrit, and Puvarasam in Tamil language. Normally, the part has to be contained the highest concentration of the principles are prepared to the therapeutic purpose and can either be the leaves, stems, barks, and root and bulb and rhizomes, and flowers and fruits or the seeds. The plants it's traditionally claimed to the process numerous effect of the medicinal properties. And based on that, the aim of my objective is to extract the dye from the selected source, and after that to apply it on the selected fabric and to analyze the antimicrobial activities. And based on this is my methodology of my work. And first of all, I have to select for the selection of the source and materials. The Dyspepsia populana flower were collected from in and around the campus, which is located in the Dindigul district. And based on that, the flowers has been converted in the powdered form, which is used by the electric blender. And after that, khadi fabric was chosen in these studies. And the extraction method, I have chosen for the 2 different extraction methods. The first one is aqueous was chosen as a solvent extraction of the dye from selected plant, and about the 10 gram of dried powder source were soaked in 100 ml of aqueous solvent in the conical flask, and after that it will be subjected to the water bath for 1 hour. And after that here soxylate extractor about 20 gram dried flour powder was finely powdered and subjected to extract by oxalate extractor. And here the ethanol solvent was to be used as an extractor, which is improved the order of the polarity of the dye substance. And after that, the pre-treatment of the fabric, the selected fabric was treated like a desizing and bleaching process was carried out, as well as the standard procedure has been carried out for the desizing as well as the bleaching process. And after that, the applications of the extracts on the fabric, the pre-treated cloth fabric was dyed with the extracts in optimized conditions. So the optimization has been carried out for each and every recipes, like concentrations and the time, the temperature and MLR ratio has been maintained. So about that, the 6% of the concentration has been maintained, and the temperature has been maintained for the 110 degrees Celsius. The MLR ratio has been maintained 1:30, and the time duration has been maintained up to 60 minutes. So after that, the mordant has been selected. So mordant is one of the essential element which is used to improve the dye affinity of the sources. So based on my study, the alum was chosen as a suitable mordant for this dye extracts. So among the pre-mordanting methods, the pre-mordanting method were found to give the better shades among than the other shades. And after that, to assessing the antimicrobial activity, here the two type of assessment were done. First one is qualitative antibacterial activities based on the ISO 20645 standards, and qualitative method which is based on the bacterial reduction percentage test. And after the assessing of the antimicrobial activity, have observed the surface morphological. Is there any type of changes can be occur or not? This can be done by the same. That is a scanning electron microscopy use a focal point being of high energies electrons to make a wide variety of signals on the surface of solid specimens. So this may result in discussion about the antimicrobial activity. So based on that the table, it shows the qualitative assessment again antibacterial activity. The first one is aqueous based treated sample. So about the 37 mm inhibitory zone against Escherichia E. coli, and after that about the 35 mm inhibitory zone of against Canadia albicans, and after that the ethanol based extracted solutions. About the 38 mm was inhibition zone of occurs at the Escherichia E. coli, and about 36 mm inhibitory zone against Canadia albicans were observed. Next. And this is a treated sample. The first two samples were aqueous based treated samples, and second two plates are ethanol based treated samples. And next one is quantitative methods, which is carry out the bacterial reduction percentage test. And this is the table which I have shown the percentage test. The first one is aqueous based treated samples, and next one is the ethanol based treated samples. So among the samples, aqueous treated samples, there is a maximum good bacterial activity was occur, 95.7% inhibitory zone against Escherichia coli, and 94.6% inhibitory zone against Canadia albicans for occurs. And next one, the sample is ethanol based treated samples. In this table, in this results has been shown the good antibacterial activities of about 97.2% inhibitory zone against E. coli, and 96.7% inhibitory zone against Canadia albicans. So this is the percentage treated sample for the E. coli as well as the Canadia albicans samples. So we can easily differentiate from the 0 hours and after the 24 hours what the results can be come out, can be easily identified based on the samples. And this is the same evaluation. Yes, the surface has been changed and cylindrical shape has been occurred after the treated of the selected dye stuffs. And from these studies, I concluded the selected Dysphagia populina flour are the best for the antimicrobial agent, particularly in the khadi fabric. And in qualitative method, the highest antibacterial activity was exhibited by ethanol extract than the aqueous extract finished fabric. And about the 38 mm inhibitory zone against E. coli, and 36 mm inhibitory zone against Canadia albicans for finished samples. And quantitative method also, there is a maximum bacterial reduction percentage has been identified in the ethanol extract than the aqueous based extract solutions. And about the 97.2% inhibitory zone against E. coli, and as well as 96.7% of inhibitory zone against Canadia albicans for the treated or finished samples. So from my point, from these sources have a great potential for the antimicrobial finish. So when the natural antimicrobial finishing is applied to the khadi fabric, it was observed that the good in microbes are resistant, which are non-toxic and non-allergic, and also is eco-friendly. Thank you. Thank you, Ananda.
Yes, Dhanalakshmi. Yes.
Yes, sir.
I hope it's your research work or hello.
So this is my research work. It's one of the chapter I have presented.
Okay, okay, fine. So I have straight two questions. First,
Yes, sir.
how did you identify the plant or the flower?
Yes, sir. Because due to my pilot study, I have selected more than 10 samples, sir, which is given the most antimicrobial agent in the selected sources, sir. So by the advisory of biologist, then I finalized this plant, and most of the reviews as reported mostly in polyester and self fabric have the good in result of the antimicrobial, particularly, sir.
Okay.
In my point, okay, if it is applied for in khadi fabric, means what is the reactions to be happen? So it may give the good results, sir.
Okay, fine. So you have the literature saying that this particular species flower having the antibacterial activity, right?
Yes, sir. Not only in the flower state, sir.
Okay.
Even here the
Okay,
seed
fine.
is there, and the plant seed is also have the good in antimicrobial activity, sir.
Okay.
But I have chosen only for the flower
Then-
source, sir.
Okay, so somebody has already done that and identified there is an effectiveness on antibacterial activity of this material. Then what is
Yes,
your
yes.
work coming into this?
So not for the particular material, sir. Here I have variated to the extraction method. Here I have only presented
Right.
only the two methods only I have given
Okay.
the results, sir. I have done for more than 4 to 5 methods I have extracted, sir. So there is an
So you are
there
going
is
to
a-
compare
the result
the,
came-
okay, you are going to compare the effectiveness of the extraction methods.
Yes, sir. Yes, sir.
Okay,
And particularly of the chosen fabric, sir.
okay, okay, fine, right one. Then second thing, when you do the evaluation against the microorganisms, you have done on some the E. coli or the two bacterial substrates, right now you have done
Yes,
the
sir.
evaluation. Have you used a control sample?
Hello, sir. Yes, sir. Yes, sir. I have used it for control for the bacterial reduction. I have mentioned for the control, and after that only it shows the results, sir, for the bacterial reduction percentage.
But bacterial reduction percentage you should always show it's the effectiveness of the treated sample minus the control sample only, the real effectiveness, na?
Yes, sir. The heart
But-
only the calculated,
But,
sir. For the 24 hours,
the
what is
log
the
value,
percentage has been?
right?
Yes.
The log value
Yes.
only you will take, na? But you have not shown
Yes,
any
sir.
log values. You have shown the percentage, na?
Yes, sir. Yes, sir. I just shown the outline of my results, sir. Here, because this is my one of the chapter my research work. That's why I just give the outline of my results, sir. Here, not only for here, I have done for the qualitative the bacterial registration. Is also I have done MIC method and agar diffusion method.
Correct.
But I just quoted.
See, you have done
Yes.
and you are presenting a data very clearly. I appreciate that.
Oh.
When you are
Yes,
coming
sir, yes,
out
sir.
with a data, you should also
Yes.
show the control sample values, na? Only then it will prove that your
sir.
material is effective. Suppose without
Yes, sir.
treatment, the fabric itself has got 90% antibacterial activity, then what is the use of the substrate?
Yes, sure, sir. I will add it.
So always you should present that your control sample value and
Well,
the treated sample value.
treated sample.
Then the log
Sure, sir,
value.
sure.
That only will show the real difference. Huh?
Yes, sir. Yes, sir. Sure, sir. In my future studies, I'll add it, sir. Thank you, sir.
Okay, fine, good work. Is there anybody would like to ask some questions to that actually? If not, yes. Good work, ma. Thank you.
Thank you, sir. Thank you so much, sir.
Thank you, ma'am. Such a beautiful presentation. Next, I would like to invite Mr. B. Venkatesh from National Institute of Asian Technology, Madhapur, Hyderabad, for the topic of sustainable approach to dye the cotton fabric with reactive dyes in presence of banana soap solution. Sir, your presentation time is 10 minutes and the interactions for 5 minutes. Kindly follow the instructions, sir. You can start your presentation, sir.
My screen is visible.
You can start your presentation, sir.
My screen is visible.
Yes, sir. Yes, sir. It's
Hello.
visible.
Okay. So, very good afternoon to everyone who is presenting. And myself, B. Venkatesh. I'm the research fellow in Pregnancy Foundation for Science, Technology and Research. And I'm doing a PhD under Dr. Kuber Sampathini. And my topic for today's presentation is assessing physical properties of banana sap treated protein fabric for sustainable reactive life. This is my topic for today's
Sir,
presentation.
Ms. Venkatesh, sorry for the disturbing, sir. Your audio is not clear.
The audio is
Keep
not
the
clear.
distance with mic.
Hello.
Sir, okay.
Is it okay now?
Sir, it's not clear.
It's not clear.
Echo.
Echo is coming. Just a second. Hello.
Sir, you can start, sir.
My voice is clear, right?
Yes, sir. It's clear.
I'm sorry for the disturbance. And my topic for today's presentation is assessing physical properties of banana sap related to cotton fabric for sustainable reactive dye. So I'm doing this work under the guidance of these figures. And I'll just move on to the next slide. Okay. So as you already know that this textile chemical processing industry is one of the significant contributors to polluting environment, and it's the second largest industry which pollute this environment, where there are chemicals, dyes, fluids in rainwater. So which needs the treatment, which needs treatments to get rid of all impurities from this wastewater. And especially if you look at this cotton processing industries, where the use of reactive dyes are more, which discharge which discharge effluents where the water contains high levels of pollutants, oxygen, BOD, salinity especially, I mean the intense fluoridation. So in order to overcome these ecological issues, this conventional dyeing system, which uses quantities of water and other chemicals, and which also causes effluent water highly polluted. So therefore, the researchers carried out investigations in developing new technologies in processing textiles for reduced use of chemicals and water. For example, based on the literature I've been through, where I got to know that different aspects may you can carry out this reactive dyeing without the use of salt, or maybe reduce the use of salt, infiltrating the cotton fabric with EDTA, ethylene, and its derivatives, pentanols, grafting cellulose with avionic acids, and sericin modification of cotton, reuse of waste for dye, low material to liquid ratio for dye, microwave radiation, use of natural dyes and solvents, and finally the supercritical cotton dioxide in dyeing. And even we can with this reverse micellar system also to do the dyeing process with this fluid and environment. And if you look at all these methods, which improves the engine working days dyeing system, reduce the use of water and other chemicals without compromising thickness. But there are still certain limitations about this. And okay, so in the process of understanding all, like by going through all this literature, so I've been going through the literature, and even a child used to see this banana solution. Whenever this comes in contact with the textile, where it stains the cloth, and it is difficult to remove this stain. So unless and until it needs sort of rigorous washing techniques in order to remove the stain from the cloth. So from there I started just going through this research, where I just started reading about what is this banana solution, what kind of composition this stem is having, and also I started going like what kind of research work is already been carried out by banana fluorescent sap in textile especially, where I found that these banana fluorescent initially started used as mordant stains also used and this banana fluorescent and then this chemical composition of it and this also this fluorescent also they started using as a coloring agent and they found that like few researchers they found that like this dyeing with the sap which demonstrates superior dyeing performance at the same time there is no compromise in the color fastness to washing, rubbing, and other aspects. And one of the good work which I can say out of this banana substance. So instead of using it as a coloring agent, they use this BPS. Sir, my voice is audible, sir. Hello,
Yes,
sir?
audible, audible.
Okay, sir. Fine. So this BPS is being used as a anti-flaming agent, like to use this BPS to achieve this flame retardance in like interesting results were obtained where they increase the alloy from 18 to 30 without diluting the BPS solution. And this is all the research literature again to uh, about this banana fluorescence app. And I thought like where we can also use BPS as a cross-linking agent, and why can't we use these treated fabric in reactive dyeing where we can reduce the use of salt without salt also. We can do this reactive dyeing process. And before doing all these things, like I need to understand the extent of changes that is being happening in the cotton fabric. Relating with this BPS, what kind of changes that are happening? Whether these changes really help me to just go for the reactive dyeing, or is there any drastic changes that are happening in the cotton? In order to understand that, even I just go through few literature where they were talking about the low stress mechanical properties and the change of physical properties, all these things. And after being through all this literature, finally I just fixed my objectives. And the primary objective of this research is to investigate the physical and low stress mechanical properties of treated cotton fabrics with banana substance and drawing comparisons with untreated native cotton fabric, so which gives me a clear-cut idea of whether I can use this fabric for reactive dyeing. Why? Because if I take this treated fabric for reactive dyeing, if it is having more changes to this native cotton fabric, then my study is not going to be in the right direction. That is what the beginning stage which I want to understand from this. And despite existing studies on banana, despite existing studies on banana solutions and treated cotton fabric, this work distinguishes itself with unique thorough examination of fabric properties. This post BPS treatment replaces that the best of our knowledge remains unexplored in the current linkage. Now, with this understanding, like I started choosing my materials. Here I chose 100%. And why I choose this cotton fabric, that is because it is used predominantly by the present scenario with mostly of reactive dyes. And the BPS solution, BPS is selected from the bottom of the banana tree, and which is filtered and used for the study with the addition of or any kind of treatment. And one more thing is that I have used this universal padding blanket to apply these bananas. And the methodology I have used is the pre-treated cotton fabric is treated with solution without any addition of water by using universal angle at 100% expression. But before applying that, we just check the pH of spray. I found that it is 6.5 with this banana solution. After that, drying and followed by curing. So where I ensure that this sap is still present in the cotton fabric. So after that, this method I have repeated till less variations in the samples. Then where I started going to the evaluation of physical properties, where I even just took the sample to the scent for the presence of the sap particles in the surface of fabric, and low stress mechanical properties based on Calvert evaluation system. And finally, I measured transition also to see whether is there any change. Is there any drastic changes between the native cellulose as well as native cotton as well as the treated cotton fabric? And these are the results and discussions. And this is what primarily the first thing I have focused, like what kind of interactions it can make. Now you all know that this is cellulose and this is banana stuff which consists of hemicellulose and lignin, and it is making the cross-linking like this. So this I able to obtain this kind of structures from my one of my colleagues is one of the professor in physics chemistry department. He helped me out with this cross-linking, how it is happening, the drawing of all these things. And I started, as I mentioned, like I want to know kind of changes that are happening in the physical properties of the native cotton fabric. So initially I started with measuring thickness on fabric weight, where I found that there is no considerable changes in the physical properties of, like especially with respect to fabric thickness and weight. So it is more or less it is same, and the standard deviations also it's very less. And when it comes to
Mr. Venkateshwar?
tensile strength, dimension, costing,
Excuse me, Mr. Venkateshwar? Sorry for the disturbing, sir. Your time up, sir. Shall we go for the conclusion?
Yes, I'm going. So these are the physical properties.
Go to conclusion, sir.
Sir, going. This is SEM analysis, and these are the low stress mechanical properties I measured, and I found that the hand value fabric. This is the color strength values. Here also I found that there is no significant difference between the color of the treated and untreated fabrics. And finally, conclusions. The treated fabrics were examined with all these things and found that crease recovery of the fabric has been improved, as well as the dimensional stability of fabric has been improved. And the same investigation also found that when the low stress mechanical properties after measuring like only after the treatment, the handle of the fabric has been improved from 1.89 to 3.5 mm. And the color strength was also not having a considerable differences between untreated and treated fabric. So therefore, this study concludes that treating the cotton fabric with this solution does not lead to considerable changes in physical properties of the fabric, so which will impact the subsequent process, especially dyeing. So these are about my conclusions. These are all references are being. So thank you. Audible, sir?
Mr. Venkatesh, you hear me?
Sir, yes, sir.
Fine. Fantastic. Yes, it's a nice area, nice approach, and
thank you.
Two things. So actually, your title says that a sustainable approach to dye cotton fabric with reactive dyes in presence of banana sap solution, right?
Yes, sir. Actually, that reactive dyeing part, actually, I'm just doing it so that I thought better to just focus on physical properties. So that's why slightly I just modified the title.
Actually, in that dyeing process, what is your expectation? That is, you are pre-treating the cotton fabric with banana sap solution, right?
Yes.
Then you are going to take it for dyeing reactives.
Yes, sir.
What is expected?
But my expectation here is, so as I mentioned in the presentation also, this sap is having a unique property of staining the cloth. So that means some cross-linking is happening with it. So maybe this kind of cross-linking, it helps during the reactive. Here I can do maybe less concentration. That is the main intention behind.
Okay, either there should be the salt reduction in the process, or there should be there should be an increase in the color value, that is K bar S values. But in the results you have shown there is no significant increase in the K bar S values, K's values.
Sir, actually the K by S values, I try to compare with this control fabric as well as this DTF banana source sap treated fabrics. With that I ensured that this is not like having any significant difference. So that when I take it to the next stage,
so you have to further optimize it. You have to further optimize it. Okay, good.
Yes,
but there is a big point here is why there is the tearing strength loss.
That's what, sir. Actually, even the literature was found. So we are just treating the fabric and drying and then curing. Obviously, it's not, the strength is not, it's not reducing drastically, but still there is a drop in strength.
Okay, see logical question I am asking. See, in the picture you have nicely represented that the cellulose, hemicellulose and lignin, they have got very close connection, right? So obviously the strength should increase after the pre-treatment, but whereas adversely the result shows the reduction in the tearing strength. That means you have to justify very clearly why it happens like.
That I'll just go to.
If you have answer, you can just tell us. Otherwise, keep it in mind and work on that.
I'll just go through.
Okay. Anyhow, good work.
Okay. Yeah, good work. Thank you so much.
Thank you, sir. Thank you for your such a beautiful presentation. And also thank you so much, sir, Dr. Saravanakumar, sir, for the completion of the session. I would like invite to Mr. K. Periyasamy sir to present the momentum for our chairperson. And again, good afternoon to all. Welcome back you all for the session 2. Totally 6 presentations are there. Before going the start presentation, it's my immense pleasure in introducing our chairperson for session 2, Dr. V. Ramesh Babu sir. He is head and professor Department of Textile Technology, Kumaraguru College of Technology, Coimbatore. He has 10 years of industrial experience in the garment field in various domains such as industrial engineering, merchandising, apparel production, quality and etc. Presently, he has 20 years of experience in engineering, education and teaching in the field of textile and apparel. He published more than 50 research papers in Scopus Journal and Conference. He fetched a grant of around 2.8 crores and 2 patents so far. He is guiding 5 research scholars and 2 scholars have completed PhD from Anna University. Moreover, he has published 6 books so far on industrial engineering in apparel production, home furnishing and fashion marketing management, apparel quality management at Woodhead Publishing and smart sewing techniques and garment engineering at the Notion Press. He has experience in NBA, NAACE, NIRF, IET, QS, accreditation and ranking process at OBE education. We are heartily welcome you, sir. Now we can go in the session 2. The first participant of Dr. Ramya from Hindustan Institute of Science and Technology. The topic is the review on development sustainability bag using banana fiber. Welcome you, ma'am.
Thank you, ma'am.
Ma'am, your presentation time is 10 minutes, then 5 minutes for interactions.
Okay, ma'am.
You can start your presentation, ma'am.
Okay, ma'am. Good afternoon to an entire present here. I am Dr. Ramya, Assistant Professor from...
One sec, ma'am. Sir.
Madam, presentation we make as soon as possible, complete the presentation, and we have a question answer section. Mainly focus on methodology, result discussion and conclusion. Okay, no, don't make more elaborate presentation. I need what method and results and conclusions. That is sufficient.
Okay, sir.
Go ahead.
Okay, sir.
My topic is a review on developing sustainable bags using banana fiber. So we all know that banana is widely cultivated crop in the world for their fruit. So after cultivation, harvesting, the trunk are going waste in the land itself. So it is very difficult for the farmers to remove all those trunks. So they are struggling to remove it. Infections are also spread from the leaves to the another plants, the new plants, and it affects the cultivations. So 1 acre of banana straw produces 450 tons of agricultural waste. So it is very difficult for the farmers to remove the waste. So we are all talking about the sustainability. So for every researcher is talking about the sustainability. So in that concern, banana fiber is a natural fiber. So we can use banana fiber for our sustainable products. So the extraction, banana fiber is extracted through the cutting of the pseudostem. Then pseudostem sheets are separated, and after that the bundles fibers are separated. Then degumming is the process using some chemicals. Then the fibrous materials are separated, and finally it's washed and dried. So these are the extraction process of the banana fibers. So now, one of the major drawbacks in commercialization of banana fibers are the lack of effective sustainable extraction methods. So, when we see that properties of banana fiber, we all know that it has good mechanical properties, good water absorption, porous and stiff fiber, breathable, lustrous, antiseptic, antibacterial, and UV protections, and anti-static in nature. So, it can be spinnable with all kinds of spinning, like open and spinning, ring spinning. So, it's lightweight and release moisture very fast. So its uses, we all know that we can use it for any art and craft materials, and it has good strength. Bags, ropes, polymers. Then we also have some banana fabrics. So it also used for food packaging materials, and it provides an eco-friendly solutions to the solutions to avoid growing plastic waste problems. So one of the toy company called Banana Co. started manufacturing food containing containers using banana fiber instead of using plastic. So it's biodegradable, compostable, and it have natural insulation for the contents. So this is a good approach. So they also have some more applications, like it also used as additives in the composites.
Hello, madam. Come to the method and result discussion now.
Okay, sir. So now we see in the plastic bags, it's very it's polluting the environment. So we are all need to reduce the plastic bag usage, so that we are moving for eco-friendly bags. So eco-friendly bags are reusable, and it can be reprocessed, biodegradable. So there are a lot of eco-friendly bags are also available, like banana, hemp, cotton bags and all, paper bags and all. So it can be reusable. So some of the research activities done using the banana fibers are using the PLA. It's combined with the blend with the PLA, polylactic acid. It is a biocompatible polymer derived from cornstarch. So it has 20% of weight of banana fiber with the 80% combination of PLA have good mechanical properties than the other contents. So these are the research activities done by the researchers, and some more activities with biofilms, biopolymers, and titanic dioxide. So they have so they also have some good results along as a final products as a bags. Some other studies also varying the mechanical properties of treated and untreated banana fiber, and it's blended with the epoxy treated. So they also have some good properties and good solutions and come with the end products. So from this literature reviews and the future applications and our objectives may be focus on the products like some N95 marks we can make using the banana fibers, and the personal protective equipment kits we can make, and some carry bags, eco-friendly clothing, mattresses and carpets. So also used for art and craft design making. So further we need to further we can also use for this to capsule covering in the field of medical, those though it is eatable. So I'm coming to the conclusion. So from these literatures, I find out, I identified that it is a most valuable plant in the world, and we can also reduce the waste produced after harvesting. So it is also helpful for the farmers to remove those waste. So it also can be used as a bags for storing and carrying the materials. And banana it itself has some waterproof properties, so it can be combined with PCL, PLA and some other natural polymers like cellulose acetate. So it can be combined, blend with those materials, and we can produce the sustainable and waterproof poly bags. So we can avoid using the plastic bags, which is polluting the environment very badly. So this is it's amongst the biodegradable. It's have a good impact in the environment. So these are the some of the references. Thank you, sir.
Ramya madam, is audible?
Yes, sir.
So this is totally review paper sort of. You are not doing any research thing. Okay. So based on this, you have any plans to do further research in this area, or just you stating some review paper over here?
Yes, sir. I have planned to do research on this area, sir.
So in the case, if you are planning for future research, what kind of things you are taking into the consideration?
So my main focus is to avoid plastic bags. So instead of plastic bags, how we can give waterproof bags. So by using banana stem and blend with some PCL, PLA, so cellulose acetate like rubber, the kind of things. So this is the plan, sir.
If you're talking about plastic replacement of plastic bags, you are extracting banana fiber, and through fiber you're going to make fabric that going to replace the plastic, or you're going to make some polymer from through polymer you're going to make a plastic.
Yeah, polymers, sir. Polymer. Going to blend with the other polymers, and the banana also converted into the polymers and blend with the other synthetic polymers. And
so how you're going to convert these fibers into polymer?
Yeah, yes, sir.
So what is the methodology right now available to convert that fiber into polymer?
There is no standard methodology available, sir, but we can crush or grind the banana stems, and we can filter, and we can settle down the fibers like so. That way we can make the polymers. So if we blend with some synthetic polymers, now we can get more strong film composite.
Okay, thank you.
Thank you, sir.
Thank you, ma'am. Such a wonderful presentation. And
thank you, ma'am.
I would like to invite Dr. D. Anita Rachel from Footwear Design and Development Institute for the topic of sustainable production of maternity and feeding active wear with vetiver and aloe vera finish. Welcome, ma'am.
Blessed afternoon to everyone. Myself is Anita Rachel, and this paper is also headed by Mr. Rajesh Kumar Sharma and Mr. Sore. We three are working in Footwear Design and Development, Noida campus. My title is Sustainable Production of Maternity and Feeding Activewear in Vetiver and Aloe Vera Finish. As due to time-consuming process, I am directly going to the methodology and what is the objectives. We just made a research on waste of the materials. We have taken that waste materials, and with that waste materials, we converted feeding wear and maternity wear for the women's. such that we three all together worked with this paper such that we produced the garment. We designed the pattern such that it might be useful for the maternity women's and the feeding women's in two different styles, so that they might be using the out of waste. We made the garment. After that, these two garments are went into the finishing stages of aloe vera and vetiver finish, because the women's might have more discomfort, worriness, stress, all those sort of things in the period of maternity and the period of feeding there, because these two are the main area or main stage of the women where they have to sustain this and come out of this period. So we designed a very comfort garment for the both pregnancy people as well as the feeding mothers, and that out of waste garment, since we are focusing towards sustainability, then that garment is meant for the aloe vera and vetiver finish. We all know that aloe vera is very herbal and natural towards us, and vetiver, the root essence, vetiver's essence, the grains are made in that finishing so that it might smell very good. It is deep, it has some stress releasing property, and all the herbal natural antimicrobial things are present in aloe vera. So after going to the dip on finish, we just made that into a full garment, finished garment, and we just tested fabric analysis, draping of the garment, whether they can wear in this course of period. What about the spelling test? How is the pilling after washing, crocking and washing? Then we made a survey such that we have taken some pregnancy ladies and some maternity ladies. We gave the garment to wear it out, and with the set of 25 questionnaires, we just gave them to analyze, wear and then to see, smell it out, where they fit everything according to the size of double XL, to make them loose fit comfortness, because thermal comfort should be there, physical comfort, psychological comfort, all the comfort properties also we studied. And with the data, with the questionnaire and the Google Forms, we reviewed that. Few people are very willing to buy such sort of herbal oriented aloe vera and vetiver finish, and they are willing to adopt. And you can see the percentage, 52.2% of women are very comfort with both the wears, and very comfort is 32%, and few people have given some grievances, some queries to change this, all those things. So just we are prolonging this research to the next stage. Thank you for the presentation. Rajesh sir, myself and Soren has done this for your grievance. Thank you, sir.
Madam, go to the conclusion slide.
Okay, sir.
So in the presentation, you only shown the questionnaires what you got from the customers.
A survey, yes, sir.
And in previous slide, I saw something about the test that you have carried out. You are not mentioned anything about the test that you have carried out for this treated fabric.
Oh, so we have done drapability test, fabric analysis test, and then washing, because the smell might go out. So we done for a washing test also. I didn't mention the tabular columns, the readings.
No, based on that only we can come to conclusion that whether this treatment is effective or not, no?
Okay, fine, sir.
And you told that the smell test, how you measure the smell test?
That just is a visual examination test, sir.
So we not did any antimicrobial, antibacterial test?
In future, we are planning for the odor test. We are seeking for the laboratories for that odor test, and the sense of odor grade, all the things we are planning in future to make this garment into a fine one.
Okay, madam. So I understood that you are in elementary stage where you took feedback,
sir.
but before taking the you are giving taking the feedback from the customers after making the complete garment. Okay, but we have to take preliminary feedback from the customers whether they need for this kind of garments or not. Then based on their feedback, you can devise your research plan or something. Now you completed everything and given the to the customer, got the feedback, but there is no any other data are missing, like what test you have carried out, what is the results have come,
Okay, sir.
whether based on that result you did some other research to develop the garments. So many
Sir,
things are
we
missing.
just step into the sustainability. So we are trying for natural items. We'll take your point and we'll go for the first survey and then we'll start it.
Okay, thank you, sir.
Thank you, sir. Thank you so much, sir.
Ma'am, kindly wait, ma'am. We want one inquiry.
Hi, ma'am.
Hi, ma'am.
Ma'am, I have one doubt. You have mentioned that you are used vetiver and aloe vera for the finishing purposes.
Yes, ma'am.
May I know the processes you are applied the finish using vetiver extract, vetiver and aloe vera?
Yeah, it is just a natural extraction and dip dry method with the padding mangles.
Can you clarify?
Pad cure dry method.
Okay, okay. Okay, thank you.
Thank you, ma'am. Thank you to everyone. Thank you so much.
Thank you, ma'am, for Thank you, ma'am. Now I would like to call Miss Indu Gupta from Footwear Design and Development Institute sector. The topic is the novel method for qualifying the blend ratio of cotton and jute fibers. Ma'am, you can start your presentation now.
Good afternoon, everyone. Myself, Indu Gupta, HOD, as Senior Faculty, Footwear Design and Development Institute, Noida campus. The topic, my research topic that I have taken today is a part of my PhD research. Dr. M.S. Pamar is my co-guide and he is the director of the lab, NITRA, and Dr. Shalini Juneja is Associate Professor, Banasari University. That is the university from where I am pursuing my PhD. So, the title for my research paper is the novel method for quantifying the blend ratio of cotton and jute fibers. Introduction. As we know, the cotton is the most widely used natural fiber, accounting for approximately 90% of all natural fiber. As we know, the cotton is mostly natural fiber.
Madam, sorry to interrupt. Directly come to this methodology and result and conclusion. Only 3 things I need. Okay.
Okay, sir. For this study, the material and methods are like, for this study, cotton and jute fiber were sourced from the NITRA. 5 blend ratio of the cotton and jute fiber were prepared at the NITRA pilot plant, and the ratios are 80% cotton, 20% jute, 60% cotton, 40% jute, 50% cotton, 50% jute, 40% cotton, 60% jute, and 20% cotton, 80% jute. Along this blend, 100% cotton, 100% jute fiber were also taken for the study. 3 fabric of known blend ratio were, of cotton and jute created in NITRA pilot plant, and 2 fabrics of unknown blend ratio of cotton and jute was purchased from the market. Then the methodology. First, the identification test was done for all the fibers. Identification test of the fiber was carried out using method as per guidelines of ITC 20. First, we have done the burning test, then the solubility of the fiber, then microscopic analysis, then FTIR, and FTIR is recorded at the VM number ranging from 450 to 4000. Then the moisture reading of the fibers were carried out as per the standard IS 199 test method. And the step that I followed for finding out the moisture reading is, first I dried with them accurately, weighed the sample in the weighing bottle, dye and clean weighing bottle. Then the sample were put in the oven at the temperature of 105 degrees Celsius plus minus 2 degrees till the constant mass of the sample achieved.
Then after having the dry mass of the sample were exposed to different humidity and temperature condition, and that the condition includes a 65% relative humidity and 27 degree temperature. Then the second condition was the 80-degree relative humidity and 20-degree temperature, and the third condition was 50-degree relative humidity and 30-degree temperature. And the sample were exposed in conditioning chamber for 24 hours. Then after calculating the moisture regain, the calibration curve is plotted between the moisture regain and the blend percentage, and the same process is repeated for the known and unknown blend of the cotton and jute fabrics. The statistical analysis, the experimental data obtained from the study were analyzed using the statistical software to find out the relation, if any, between the moisture regain and the blend percentage of the fibers. Then the resultant discussion. For the identification 10, the burning test shows that the fiber is behaving like the paper while burning, so it shows that they are cellulosic in nature. Even the solubility test shows they are dissolved in 70% sulfuric acid, so confirm the cellulosic in nature. Then the microscopic view of the fiber is here. Then the for the cotton fiber, it shows the ribbon-like structure for the longitudinal view and the kidney shaped structure for the cross-section view that confirm that it is cotton in nature. For the jute fiber, the longitudinal view of the jute is cylindrical and its diameter is having horizontal marks like joints. Cross-section views show polygons with rounded edges and central lumen. That is also shown from different studies that also confirm that it is jute in nature. Fourier transform infrared study, FTI. FTI study for the cotton and jute fiber, also for the blend of the cotton and jute was compared with the individual fiber. This is a graph for the FTI studies. We can easily see the red graph is shown for the cotton, the black is for the jute, and the blue for the cotton and jute blend. We can see from the graph that the peak absorption for at the wavelength, a different wavelength, is similar in all the three blends. So that also confirm they are cellulosic in nature. Even from this table, we can see the highlighted mark, the 1508 wave number that is shown in the jute, also in the cotton and jute blend, but not visible in the cotton. And this wave number is the characteristics of the lignin, and that lignin is not present in cotton. That also confirm the identification of this fiber. Now the quantification of fiber in the known and unknown blend. As I earlier told you, 5 ratio was prepared. Moisture regain of the 5 ratios was done. 80-degree cotton, 20% jute, 60% cotton, 40% jute, 50% cotton, 50% jute, 40% cotton, 60% jute, and 20% cotton and 80% jute. And then they are exposed to different humidity and temperature condition for the 24 hours. And these are the condition that I earlier told in the last slides: 65% RH and 27-degree temperature, 80-degree RH and 20-degree temperature, and 30-degree temperature. Then the graph is plotted between the blend percentage and the this humidity moisture regain values. And we can see from the graph, with the increase in the percentage of the jute fiber, the moisture regain is also increased in all the three conditions. That is 65 RH, 50-degree RH, and 80-degree RH. And now the statistical analysis. The regression coefficient value was 0.980 was obtained for the blend of cotton and jute, and this value shows that there is strong relationship between the blend percentage and moisture regain in the blend. The blend ratio through the novel method. Now I have mentioned in the materials slide that I have created 3 known percentage of the blend, that is 80% cotton, 20% jute, 50% cotton, 50% jute, and 60% cotton and 40% jute. And then I have calculated the moisture regain value at the standard condition, that is 65 RH and 27-degree temperature, and the moisture regain value are given in column 2. And I can show you from this graph that the blue curve is showing the blue shape curve with the calibrated curve between the blend percentage and the moisture regain value, and that I have created the 5 ratios. Then I have plotted. Then for the 80% cotton, 20% jute, the known value, blend ratio, the moisture regain value 8.3, I have plotted on this graph. For the 8.3 moisture regain, we can see that the blend percentage is coming out 22 for the jute. So the counterpart 78% is cotton. That is very close to the 80% jute, 20% known percentage.
Ma'am, Indugupta ma'am.
Yes.
Sorry for the disturbing, ma'am. Time is in, ma'am. Shall we go for the conclusion?
Yeah, okay. Similarly, for the known cotton, 50% jute, 50% blend, I have find out that the moisture regain value that is 9.6 for the 50% cotton jute and 50% jute, and for the and in the graph it is showing the 53% cotton, 47% jute. That is also very near to the known percentage. Similarly, I have taken 60% jute, 40% jute, 60% cotton and 40% jute, and from the moisture regain, the value came out to be 62% cotton, 38% jute. And for the unknown sample that are sourced from the market, the blend percentage came out to be 42% cotton, 58% jute. And for the sample 2, it is found out to be 63% cotton, 37% jute. Now the conclusion that the statistical analysis showed that there is a strong relationship between the blend percentage and the moisture regain. As the moisture, if the in the blend percentage, if the percentage of the fiber having higher moisture regain is increased, then the then the moisture regain also increased. The analysis of the known and unknown blend using the novel method also revealed that the blend percentage found through the novel method, moisture regain method, is very close to the actual percentage of the fiber. Thank you, sir.
Madam, where did you find the literature evidence for this kind of novel method? There is any previous literature stating this kind of?
Actually, literature review, like first of all, I have sent the, I have confirmed from the different laboratory itself, that is my primary research, if there is any method for the quantifying of the cellulosic blend. So confirmation from the many laboratories come out, there is no method for quantifying this cellulosic blend. Because they are both are chemical in nature. Then many studies like literature review, one of the reviewers showing that they have used the fineness method, fineness property of the cotton and jute to find out the this blend percentage. So on the similar track, I have used this moisture regain property to find out the moisture regain properties of the the blend percentage of this blend.
So the solubility test is very easier than this. Then why you have to go for this complicated method?
The FTI, sorry, yeah. You are asking about the FTI test, sir?
No, I am not able to get you. So here there are so many tests to measure this blend proportion. No, the solubility test what you are stating, no, that is very easy compared to test what you are doing. Why you are making complicated things?
So because solubility test, if we use cotton and jute, they both dissolve in sulfuric acid. So it is very difficult to find out the quantification from this solubility test method. Quantify, it is very difficult to quantify.
Ma'am, I think you are speak closely to your mic. Keep away the mic. Your voice is not clear, ma'am. Yeah.
Am I audible?
Yes, ma'am, audible, but your voice is not clear. Keep away with your mic.
Okay.
So how you are making the graph respect to moisture regain and the blend percentage, and
Yes,
through that you are deriving the proportion of jute and cotton. If you fix any constant things like you are fixing the moisture regain as a constant or blend proportion as a constant?
That's that blend percentage is constant. That I have mentioned in my materials method. I have prepared the 5 blend ratio, 80-20.
No, based on the regression equation, you are deriving that the blend proportion, or how you are going to derive that blend proportion? You are predicting the blend proportion, no? If suppose 60-40.
I have prepared the blend proportions.
Once again repeat, I couldn't get you.
Yeah, I have prepared these blend ratios in the ratios in the lab, the fiber stage.
Okay, thank you.
Thank you, Ms. Indhu Gupta ma'am. Now I would like to call Dr. P. Gopalakrishnan from Footwear Design and Development Institute sector. The topic is Sustainable Waste Control in Apparel Industry. Sir, you can start your presentation now.
Blessed afternoon. Once again, it's Dr. Anita Rachel. Myself and my co-author, Dr. P.P. Gopalakrishnan, sir, has made this a study. It is a study thing. Just we taken 2 to 3 apparel industries in Tirupur to study about the sustainable waste control in apparel industry. So let me start with what we have done and what are the solutions we found out. So since time is concerned, I'm just telling the problems we faced with the 3 concern of major factories who is heading the industrial engineering and they have bulk orders, how the sustainable waste control system is done. What is the strategies of waste control management? We just focus on that. It is also a preliminary study. We started with 3 companies. Then we are fetching for the more thing as a research paper. The first problem we saw in that focusing towards the sustainable engineering techniques, we have there is a more emission of carbon dioxide, and then we found some non-recycled products are just kept it backlog. It can be recycled. Then we found some strategies how to reuse it, recycle it, refashion it, because we are in the fast fashion world. We have to reduce the cost for all the operational efficiencies, all those things, and we have to build, recycle, reuse it to optimize from starting point to till end. All those things we are planning for that. That problem also we face there. And also the main thing, the sustainable is not only to minimize the material, minimize the thing, maintaining the time is also comes under. We should not waste time also. So we also concentrated how to improve the time management, how to improve the culture of the employees, how to make the customers satisfied with the less time with a more profit. All those things we have taken study on 6 branding techniques, 6 brands in 3 companies of apparel industries in Tirupur. One is Anugraha Fashion, then BS Apparel, and then New Line Apparels. All are in Tirupur. We just concentrate on waste management alone in that. In that experimental part, we just made a study of daily production status of waste materials, how much kgs has been wasted, and then how we can reduce the boiler things, pollutions, and then reduction of carbon dioxide. What are the waste materials in cutting, how we can reuse it. These are the collaborations we just did it. And what is the end product of that? It can go for reginning, or it can combined as another, go for other sido spinning systems and converted into yarn. We just sort of that. We are planning to collect all those things. Just we are concentrate only on this 5 topics, that is waste prevention, how to prevent waste, waste minimization, how to recycle it, and what is the landfill. We should not pollute our land. We should not waste our time. These are the concepts we have just taken, and we found that many fabrics are waste. Even though yarn rate is more, many sort of kgs of fabrics have been bit fabrics also waste. So waste, we are planning to reduce the waste management. And in what way? It might be a trolley way, it might be a in-person absorption way. What are the strategies and concept in waste prevention management we have to implement in that company? Each unique labor has the thought to prevent this is our company. We should not waste the time. We should do something for the environment. We should be society conscious. We should be eco-friendly. We should serve our company, our nation. That intention by motivating the laborers, making them behaviors, improving their body language towards our company, all those sort, time concept, on time, quick response, such sort of many studies we are doing on that. We are just improving the time system, that is method study and time study. Within that time of slot, how we can prevent the waste management. These are the surveys, preliminary test we are taking in the 3 companies. It is just what we did in the experiment level. We are just exploring for the presentation. So I conclude that sustainable fashion is very, very important. We are in a trendy, fast moving fashion world. So we should have some environmental impact, and we should serve our nation in a concept of zero waste management. Thank you.
Madam, again you are taken very big topic and there is no any clarity, and finally you are concluded something. So you are talking about wastages and that wastages which are going to spoil the environment. Other side you are talking about method study and time study. So how this going to connect, that I don't know. And still this presentation is basically not any research work. You are trying to collect some information and presenting the overall thing on some waste management. So there should be need more clarity, and if you future
Okay,
you
sir.
going to carry out research,
Okay, sir.
focus on certain areas and explore that. Okay, so with
Okay,
this we cannot conclude anything, and if you planning to do something on this, just please focus on some area and explore that. That is our
Okay, sir.
suggestion.
My focus is on waste and hazard minimization.
Okay, thank you. And one more thing, so I can see you people are working in footwear design and development, and all people are talking about more relevant, mostly on textile and finishing.
Vanitha
And
ma'am, can
so,
you unmute your video?
So why there is no any research on footwear?
Okay, sir. We'll try it and we'll post it in the next thing.
Okay, thank you, thank you.
Thank you, sir. Thank you so much. Thank you to all.
Thank you, Dr. Anita Rachel ma'am. Now I would like to call Dr. Ruma Chakrabarti ma'am, OETA India. The topic is Sustainable Apparel and Fashion Through Circular Ecosystem. Ma'am, you can start your presentation now, ma'am.
Good morning, Gurunath. Good afternoon, sorry.
Welcome, sir.
Yes, ma'am, yes, please.
Dr. Saravana Kumar sir from Dr. Silva Kumar sir from VIT. We are heartily welcome you, sir.
Thank you, ma'am, thank you. I can share the presentation now and proceed.
Yeah, okay, sir.
Hello, Dr. Selkumar. Audible? So, Dr. Selkumar, audible to you? Okay, Doctor, we are running short of time, so you just please rest.
Yeah, okay, I can proceed, sir. No issues. Yeah.
Hello. Okay, Doctor, please restrict your speech to 5 minutes, please. Hello.
Fine,
Yeah, so we are running short of time. Sorry. Thank you.
No problem, sir.
Thank you.
Very good morning, very good afternoon, one and all present there. So, I'm very happy to present the topic related to the latest developments in smart technology for textiles and clothing. So, it may be nowadays that the smart textiles are very popular and booming field in Europe and other countries. Apart from that, other developed countries, India also. So, looking for many smart wearable technologies for meeting the demand of the people, and we have a huge demand on the latest developments as well as the regular smart technology for regular usage for serving the society. So usually this smart materials, the content I wanted to go ahead with this very shortly that I'll project it. Smart materials and embedded electronics, PCM and SMP connectivity. This is just I wanted to give the gist of the content with this the same slide. Smart materials, the smart materials are defined in different ways. Intelligent textiles as well as we have smart textiles or specialty textiles. In the name of different terminologies, the smart textiles are given. The name is given and the material is proposed. With respect to the smart materials, it behaves smartly with respect to the conditions. That is the main important function of the smart materials. The materials, we can call it as smart materials. It will perform with respect to the particular climatic conditions. So, for example, temperature is one of the parameter. Even for magnetic flux, also one of the parameter. The force also one of the parameters. And pressure is one of the parameters. Even for hot weather and cold weather, these are all the conditions where we are living. So the materials will perform and give the functional property with respect to the external conditions. So mostly the smart materials are developed to enhance the living style of the people who is in the medical or as well as who is in different climatic conditions for high altitude and even high cold and high hot weathers, right? This is the very important thing. Many of the research is going on. The second one is the embedded electronics. The embedded electronics, in the sense you can attach some of the sensors and components in the textile substrates. By the way, you can go for some applications. Say, for example, for temperature monitoring, we can embed temperature sensor in any of the jackets in the regular wearings. We can connect through the internet, and we can connect even iPhone watches, even smart watches for all the brands. You can connect and you can get the records of your measurements. And again, the regular, there's mostly that you have all of us having the smartphones, and the smartphone having that the embedded electronics systems, which will give the status of your regular day-to-day activity. Say, for example, some phones will give you sleeping patterns, some phones will give you uh, the walking steps, and some phone will give you this the calorie you burned because of the steps you covered during the regular walking. All the things will be done with the help of this embedded electronics. I think it may be, yeah, it is possible with the help of the textile substrate as well. And PCM and SMP is a new word. It is nowadays many of the research, industrial research, are concentrating on phase change material as well as shape memory polymers. So highly, these two materials are novel materials in this decade, and researchers are doing many researches on these materials to adapt to the particular climatic conditions. So the materials will behave accordingly. So the property of the materials, phase change material will change the phase. So for example, we know solid, liquid and gas phases. The material will become a solid to liquid will be this the regular wax, right? We know this, all are aware about this. Wax will be the phase change materials will, if you heat the, it will be liquid. So unless it will be, if you cold it, if you just warm up, or if you give a cold conditions, what happens? It will become solid. Such a way that changing materials will be there, and not only with the paraffin, many materials are having certain properties. We can use it for thermal regulations exclusively in the jacket. The material, shape memory polymers also. It's one of the important material developed for developed to meet certain applications. So for example, at high temperature